So morning again, guys. Continuing the topic that we're on, which is functions, and we're gonna go through this classwork, as I said. And the idea is that persons who got anything wrong should go and do the question again. This classwork, even after I explain it, you need to go and work the question again by yourself, especially the parts that you got wrong. All right, that's how we move forward. The focus of today's class is to do some functions topics, some aspects of the functions topic that are not set very often in exam. Because they're not set very often in exam, you find that persons tend not to answer them correctly or to the fullest when they're actually set in exams. So these are, you're not going to see a lot of questions with these examples. You're not going to see a lot of past paper questions with these examples that we're doing today. All right. We also want to do the variations topic. Depending on how far we get today, we might do it today or we might decide to do it tomorrow. All right. Maybe I prefer to just do it today so that tomorrow's class is just a class where we're working examples. All right. And then the classwork on Wednesday will comprise of these special functions questions and also a variations question. All right. So, but first we're going to start by going through this classwork as revision as usual, and just to clarify anything that persons misunderstood. And if you have any questions along the way, just let me know so we can stop and explain it. All right. Because this is the simplest form of the functions. And you have to understand the simplest form of the functions before you can do, the more in-depth parts of it. All right. So these are exam past paper questions as usual. So these questions actually came off exam past papers. All right. They're very easy. All right. But we just have to be careful with some of what we do. All right. All right. So question one. So question one gave us those two functions, f of x and g of x. F of x is what we call a rational function because it's in the form of a fraction, a ratio. All right. So it is that f of x is equal to 2x minus 7 divided by x plus 1. And it also gave us g of x. And the g of x function is a power function, square root of x plus 3. That's the same as x plus 3 to the power half. That's why I'm referring to it as a power function. All right. If we were to write it as an index. All right. So part A, very simple. Part A wants us to find g of 6. And remember, at least one person made the mistake of putting the 6 in the f function. It was a mistake. All right. We learn from our mistakes, so no problem. But because it's g of 6 we want, the g of 6 is supposed to go in the g function. That's where we're supposed to put the 6. All right. So g of 6 means that 6 is going here, and therefore 6 is going there. All right, and that's how we work it out. So it becomes the square root of where the x is, we now put 6 plus 3. That becomes the square root of 9, and the square root of 9 is 3. And so the answer for that one is 3. All right, part B is asking us for f of g of 6. An important thing to note here is that we know the g of 6 already. We just calculated it here, and it is equal to 3. And remember that f of g of 6 really means you have to do the g of 6 first. And we have it already, so there's no need to redo it. We have it already. And another way of expressing this is to say f of g of 6 is the same as f of g of 6. The same thing, meaning that we're doing the g of 6 first. But we know that g of 6 is 3, so this becomes f of 3, because the g of 6 is 3 right there. And then f of 3 now means that we are putting the 3 in the f function right there to work out f of 3. All right, and this question was well answered. Most persons, I think, got it right. So we're putting 3 in that function now. So it becomes 2 times 3 minus 7 divided by 3 plus 1. That 3 is where the x was. And then work it down, carefully. So this works out to be 6. 2 times 3 is 6. 6 minus 7 is negative 1. So that is negative 1. And the 3 and the 1 there is 4. So it's negative 1 over 4. So it's negative a quarter. And most persons got that correct. All right, nice and easy. Then the next part now, let's just move down to part C. It's a different question. So part C, 1, is asking us to find f to the minus 1 of negative 1. All right, that's what they want. To find f to the minus 1 of negative 1, what we're going to do, we're going to find f to the minus 1 of x first. Do this first. And then we're going to use this to find the f to the minus 1 of negative 1 that we want. So it's that first, and then that. That is a procedure to do it. F to the minus 1 of f to the minus 1 of x first, and then f to the minus 1 of negative 1. So find the inverse function first. And most persons did not do this right. I just practice any, you're on the right track. We will just need practice how to transpose, believe me. The inability to transpose is one of the main cause of persons not getting questions right in exam. You know that you're supposed to transpose. You know the right thing to do, but the skill to actually transpose is what is causing the problem. So persons know the right steps to do, but not executing it properly. So you need to practice how to transpose. You need to practice how to simplify. And to do that, you have to understand the BODMAS system, right? And don't worry about it. We'll practice and practice and practice, and you'll get it. So we don't have to do a class on that. You can, do some of it for yourselves, right? Because if you find that you have a weakness, you need to work on it to strengthen yourself, right? So persons had the right start for this, but they just did not transpose properly. All right, so the procedure is just, okay, this is the f of x that we're working with. This is the f of x that we're working with. So I want to start by saying f, we're going to put this f equals 2x minus 7 over x plus 1. And this is our function. And what we want to find is the inverse. So we're going to inverse it. And we know the concept of the inverse is that the domain, the range of the function becomes the domain in the inverse, and the domain in the function becomes the range in the inverse. All right, and so we reverse the representation of the range and the domain from the function to form the inverse like this. So we'll say, okay, this is the range of the function. It becomes the domain of the inverse, which is represented by x. This and this each represent the domain in the function, and so they become in the range in the inverse. Just like the range in the inverse, to make the distinction, to make the difference, the range in the inverse is written with a f as f to the minus 1. So it becomes 2 times f to the minus 1 minus 7 divided by f to the minus 1 plus 1. And now all we need to do is transpose to make these things the subject. All right? That's all we need to do now. We want to make f to the minus 1 the subject. So essentially what we have done, we have formed the inverse function. So this is the inverse function, just that we don't yet have f to the minus 1 as a subject. So we have to transpose it to make f to the minus 1 a subject. All right. So the first thing we say, okay, we're going to treat this under here as if it is one expression, and then we're going to multiply it across here by the x. So it's basically multiplying both sides by this thing under here to cancel it, to remove it from there. We don't have to show that step, right? We're practicing. We don't have to actually show the step. We just know that we're multiplying the x by this value and also multiplying the x by this value. And we'll go step by step. All right. So when we multiply across, you're going to get x times the f to the minus 1 plus x times the 1 is x equals, and you get this back. That is left back, which is 2 f to the minus 1 minus 7. Then what we want to do now is group all the terms with f to the minus 1 on this side and everything else on the right side. So what do we need to move? What do we need to move? We therefore need to move this expression with f to the minus 1 over here. And we need to move this x over onto this side. That's the transposition that we need to make. All right, so let's go and do it now. So we're going to leave this x times f to the minus 1. And when this comes over onto this side, it becomes a minus. So change the sign to negative 2 times f to the minus 1. It's just the same as saying you subtract 2 times f to the minus 1 from both sides. But this is just a shortcut way I'm showing you. All right? This is equal to. This negative 7 is already on the right side. So it's going to stay as negative 7. And then this positive x comes over this side and it becomes negative x. All right? So it becomes negative x when we transpose it. And just the same as I said as subtracting x from both sides. So now that we have the terms with f to the minus 1 on the left side, we can factorize it. All right? I really want to express f to the minus 1 alone as a subject. So we're going to factorize f to the minus 1 out of these two terms now. And so this becomes f to the minus 1 bracket. From this, we get the x. And from this, we get the negative 2. And then this stays as negative 7 minus x. I didn't do another change over there. And then what we need to do now is divide this x minus 2 under here. Same as saying we divide both sides by x minus 2. Divide this side by x minus 2. Let me show it in red. Same as saying we divide this side by x minus 2. And also divide this side by x minus 2. Theoretically, that's what we're doing. Right? But I like to show us the shortcut way, so we don't have to write too many steps on the exam paper and waste time. Right? So we know that we have this over here. We're just going to divide it. Right? Here is multiplying. To cancel it, we're going to divide it under this side. All right? So we don't have to show that step. And therefore, we're left with f to the minus 1 equals negative 7 minus x divided by, and x minus 2 ends up under here. And that now really is a function of x just the same. So we can put back f to the minus 1 of x. So we have done the first part, which is to find f to the minus 1 of x. Now that we know f to the minus 1 of x, we really are trying to find f to the minus 1 of negative 1. So it means that we have to substitute the negative 1 here, here, and there to get f to the minus 1. Right? We need to substitute f to the minus 1 those 3 places. Here, here, and there. So we can have f to the minus 1 of x, which is what we want to find. All right, so let's do it in the next line now, right here. So coming to our answer now. So we can say, therefore, f to the minus 1 of negative 1. Remember now, when you're doing maths and you come upon negatives, so much negatives in there. This is negative, this is negative, this is negative, this is negative. All right, and this is going to be negative. I'll substitute negative there. So when you have all those negatives, you have to be extra careful because most mistakes are made in exam with the negatives. Mistakes are made with transposing. Mistakes are made with the negative. So you have to be careful. Learn how to not make those mistakes. It will come over time with practice. So anyway, put in negative 1 here and here now. All right. So it becomes negative 7 minus x is negative 1 divided by negative 1 minus 2. And all those negatives, as I said, will become extra careful. This minus here becomes a plus. So we can write it. It is negative 7 plus 1 divided negative 1 and negative 2 becomes negative 3. So we have negative 3 under here. Okay, adding 2 negative values, so we have negative 3. The negative 7 plus the 1 is negative 6. So that therefore is negative 6 over negative 3. Then the negatives cancel the negatives. And then the 6 divided by 3. 6 divided by 3 is 2. And so the answer right there is just 2. And that is the answer. So those who did not get it correct, you need to go and work the question over by yourself. Please and thank you. Very important. All right. The next part over here, wants us to find g to the minus 1 of 1. So inverse in the g function now. All right, so let's go to that. And it's the same procedure. Find g to the minus 1 first, and then we'll substitute the 1. So let's go part 2. We're trying to find g to the minus 1 of 1. That's the inverse function, inverse of g, and we want the image of 1 of that inverse function. So let's see it again. What do? We find g to the minus 1 of x first, then we substitute the 1 to get g to the minus 1 of 1. That's the procedure. All right, so let's go. Same steps basically. We're going to start by saying g equals the square root of x plus 3. Just leave off the of x for the time being. Just leave it off for the time being. Right? So don't put it. I'm trying to simplify it as much as possible. So leave it off first. And then this is the function now. This is the g function. And then same thing again, we're forming the inverse function. So the g, which is a range, or which represents a range in the function, becomes the domain in the inverse, which is x. And then where the x is right here, which is the domain in the function, becomes the range in the inverse. And the range in the inverse is g to the minus 1 plus 3. So I've actually formed the inverse function. That's the inverse function, you know. Just that we need to make g to the minus 1 the subject. So the first thing that we need to get rid of the square root sign. We're trying to get them from under the square root sign. The inverse of square root is square. So essentially what we're doing to get rid of that square root is that we are squaring both sides. We're squaring both sides to eliminate the square root, because the inverse of square is square root. And when we do indices, we can, you know, appreciate this a little bit more. But for now, you want to get rid of the square root on that side, you square both sides. So that's what we're doing essentially. So let me move them now. So when you square both sides, you end up with x squared being equal to just the g to the minus 1 plus 3. And then notice I want to have taken this g to the this negative 3, bring this positive 3, bring it on this side, and it becomes positive, it becomes negative 3. Same as saying you subtract 3 from both sides. Alright, so we're going to have g to the minus 1 by itself equals x squared minus 3. And this really is g to the minus 1 of x. So we can put in back the of x now. So g to the minus 1 of x is equal to x squared minus 3. So we have completed this part of it. So what we need to do now is substitute the 1. So we can go back now and say, okay, therefore, what we really want is g to the minus 1 of 1. So we're going to substitute the 1 here and there. All right. And so it becomes 1 squared. That's a 1 squared from that minus 3. 1 squared is just 1 minus 3. 1 minus 3 is negative 2. Mute your mic, please. Mute your mic. Mute your mic. All right. So we'll finish that part. Mute your mic, please. Mute your mic, please. All right. So we'll come to part 3 now. All right, remember, as I'm going, you know, if you see anything you don't understand, stop and let me know, you know, so I can explain it. All right. Don't make sense to come to class and I'm here, and then after class you're going to burst your brain to figure out something that I can just tell you easily, quick and fast. Just ask me anything you don't understand. All right, don't come here and just be quiet and see something you don't understand and don't say anything. Ask me. Let me explain it. All right, so coming to part 3 now. I'm trying to explain as I go. If you're not clear on something, just ask me. All right, so I'm trying to do g of f now. G of f of x. We all know that g of f of x means f followed by g. F followed by g, same as saying putting f into g. So g of f means f first, and then the result of f goes into g. Right? Or we can say it is just f into g. So g of f means, in terms of what we do, it means f into the g. So putting the f function into the g function. So let me write them over back, write back the function so we can mark what we do. So the f of x function is 2x minus 7 over x plus 1. And the g of x function is just the square root of x plus 3. And note that everything is under the square root sign right there. And if we put in the f into the g, what does that mean? That means this composite function is formed by taking everything that f is, and you bring that and you put it into the g for x right there. And everything must still be under the square root sign. That's how we form the f into the g. So the whole f function going into the g was going where the x values are. All right. So when we do that substitution, our result is going to be that the f of g of x is going to become, you put a big square root sign because you want everything to be under the square root sign. The x was under the square root sign, so this f that we replace the x's with must also be under the square root sign. And where the x is, you put all of f there. 2x minus 7 divided by x plus 1. That's where the x was. And you put the plus 3 beside it. And you make sure that everything, so when you draw the square root sign big, see it? Come on, make sure everything is on the square root sign. Some persons did this. Right? Some persons did this for the square root. They put the square root right up here alone. It's not the same, that is wrong. Right? Because it looks as if it's everything under the square root up there divided by the x plus 1, which is a difference. You have to show it that everything is under the square root sign. All right? That's what you have to do. That's what it's supposed to be. Make sure, make it clear to the examiner that everything is under the square root sign. That is the answer for that one. All right? And then we could just do a little extra. Let's say we refine it. If we refine it the other way around, what would that mean? All right? So this is the answer for what we did in that. That's the answer for part 3 now. This is the answer for part 3. And this also was well answered. I mean, almost everybody got that right. But let's say we're doing f of g of x. Let's say we're doing that instead, f of g of x, just for practice. F of g of x means now, it means g into f. That's what it means, the inner one into the outer one. So this is g into f. That's what that means. Let's write them again so we can show what is really happening. After a while, I don't have to write them, but I'm just doing it now, just to demonstrate. So we have the f function, which is 2x minus 7 over x plus 1. I have the g function, which now is the square root of x plus 3. All right, so I'm just doing a little bit of extra work now, as if the question was to find f of g. How do we find f of g? You put g into f. So let me mark it now. We would have to put all of the g, which is what this is. Let me use the red to show it. All right, we'll have to put all of the g. I'll have to put it into the f here. And also here. Or everywhere x is, we'll have to put all of g there. And when we do that, the result would have been that the f of g of x, which means g into f, would have been equal to fraction 2 times, where the x is now, you put the square root of x plus 3. Right? Write it properly. I write it lower down so you can see clearly. Right? So if we're doing f of g of x, which means the g into the f, we'd have to write 2, where the x is, you put all of the g, which is the x plus 3. You have to put by the minus 7 beside it, and then everything would have been dividing by the square root, where the x was, we're putting back f plus x plus 3, square root of x plus 3, and you have to put by the plus 1 beside it. That is how we would form that f of g, if the question wanted it. All right, but they didn't want that. All right, so that was question 1. taking my time in them because I wanted to understand it, especially for persons who were not here. All right, because we have a couple new persons today. All right. All right, so let's go now. Question 2. And these things very easy, you know, so don't worry about it. If you don't fully get it now, don't worry. So by the time we do 1 million of these questions, practice them. All right, you will get it nice and easy. All right, right now I'm just getting you the information. You're gonna master all these things over time. So don't worry if you don't 100% get it yet. Getting enough now, so that you know when we're ready to practice and go through our exam prep and revise. Right? All of these things will become very easy for you. Trust me. Believe me. Right? All right. So we have this next question now. I'm looking at question 2 now. And question 2 gave us that graph. I'm just gonna resketch the graph. All right. Now notice that on this diagram with that function, there is a dot right here and a dot right here. Those 2 points are highlighted, meaning this one passes through the origin. This one passes through the point. Based on it, they're giving us these 2 values. That is the point 33. All right, and that was significant. All right, so let me clear it. All right, so let me see if I can resketch the graph. So I gave you something that passed through the origin right here, and then it took a shape, something like that. All right, so let's say that is it. Not example, that is it, and this is f of x. That's a function that they gave us, and then they gave us a point 33. So let's say 33 is right here. So right here is 3. Right here is 3. All right. And the question said the diagram in the sketch is a function f of x which passes through the origin. See, that's what the mark is in the origin O, right there, and the point 33. So that's helping us. It says redraw the sketch and show the inverse function f to the minus 1. And it says draw the line which represents the relationship between them, between f of x and f to the minus 1 of x, and state what that relationship is. Now, the line is the line y equals x. All right? We know that y equals x is a line representing the relationship between them because they reflect each other in the line y equals x. F of x and f to the minus 1 of x are reflections of each other in the line y equals x. All right? And so I'm going to draw that line first. Now, that line must pass through 0, 0. I must pass through 3, 3. Well, it passes through points where the x and the y values are the same. All right? So draw a line passing through those 2 points first. Not so accurate. Let's go again. Still not so accurate. Everything important. Good. Better. So that's my line. I'm going to label it. Y equals x is a line representing the relationship between them. Y equals x. And some persons write x equals y. It is correct, but generally speaking, you make y the subject when you're writing an equation. All right? So y equals x is a line. And then the inverse, now I'm going to draw the inverse in blue. Right? Now remember, the inverse will pass through points where the line and the function meet. The inverse will pass through points where the x value and the y value is the same. Right? We always pass through points where the x value and the y values are the same. So let me write that as maybe AA. Pass through AA points where the x value and the y value is the same, whatever those values are. So 2 points are going to pass through on this diagram will be this point, which is 0, 0. The inverse will pass through that point. And also this point, which is 3, 3. So the function and its inverse will always intersect the line y equals x at the same place. Right? Now, what I found is that some persons in this classwork, right, they drew their function up here and go like that. No, it have to pass through. He said the only way it could do that way is if the original function they pass somewhere down here. I suppose this point was 0, 2. No, not 0, 2, 2, 0. Suppose this point was 2, 0. Then it would start here, 0, 2. But that is not the case this time. It passes through 0, 0. So let me erase all of this now. Passes through 0, 0. So the inverse must pass through here as well. And also will pass through here. And must look like a reflection in this line. Must look like a reflection in the line y equals x. So you have to draw it such that it looks like a reflection. So I'm going to draw it in blue. I'm going to take a piece of it over because the function gone under it. So the inverse is going to go over it by about the same distance. So that it looks like a mirror line. Right, like that. And then this one goes up as if it is going sort of parallel to the y-axis. Right? So this one is going to go more down and go like it's going parallel to the x-axis. Like that. All right? And I put a little arrow on top here. And this now is f to the minus 1 of x. It looks like a reflection. It looks like this is a line of symmetry. When you finish, the line y equals x must look like a line of symmetry. And one way of ensuring that that happens, that it looks like a line of symmetry, always sketch it. So basically, your x scale and your y scale is the same. So I'm putting a point 3 here. You want the distance that from here to here to be about the same here. 3 there. But you don't want 3 here, so, and the next 3 is way up here, so. Right? You're trying to use the same scale on the y-axis and the x-axis when you're drawing these diagrams. Because what it does, it allows the diagram to look more symmetrical. Because then the line y equals x will be right down the middle of the graph at 45 degrees. I think we spoke about that in the last class. But basically, that's a good sketch. Good enough sketch of the function at inverse. The red line there, which is the line y equals x, looks like a line of symmetry. Then the question now says, we have to draw the line, that is the line, and then we have to state the relationship between the function and the inverse. And this is always it. Don't write anything different. All right? Don't try to create the relationship between them. Anytime you ask that question, always write this. Right? That relationship between f of x and f to the minus 1 of x, that is the function and its inverse, is that they are reflections of each other in the line y equals x. If you write that to get the full marks in the exam. So this reflect to get this, and this reflect to get that. And they are reflecting in the line y equals x. Similarly, this part reflect to get this part, and this part reflect to get this part. And the line y equals x is like a mirror line. Or the transformation might appreciate this a little bit more. We're gonna see that same line as one of the transformations, or with the transformations, the topic of transformation. I'll see that x and y values interchange, or reflecting line y equals x. But that's the relationship between any function and its inverse. All right, and remember, only a one-to-one function can have an inverse. All right, so that was a classwork. Any questions there? Everybody good with that so far? I'm moving on now, you know. Everybody all right? Somebody answer like me that you're hearing. Everybody hearing? Somebody
Yes,
say
sir.
something.
Yes, sir.
Yes, sir.
All right, good. All right. So what we're gonna do next now? We're gonna look at some topics in functions that, as I said, they are not set very often. That's what we're gonna do next. Some functions topics that they don't set very often. It's hard to come on exam paper. So when we finish doing them today, you have to, pay attention, make good notes, and put what we do today in a special place Because you might do 10 exam past papers and you never see one of these questions. You might do 20 exam past papers and you never see one of these questions. And even if you see one of these questions, it might be just one. These things that we did today, these things are the normal things that they ask in exam. All right? The normal things. If you, for example, look at the worksheet that you have here, most of the questions asking the same thing. Find the image of a function. Find the image of a composite function. Find inverse and so forth. These composite function things. Those are what they normally set for the exam. So these things that I'm doing today are the things that they don't set very often. And even though they're very, very easy, you know, believe me, they're very, very easy, super easy. Because people don't see them every day. Right? People don't see them every day. People tend to forget them. And when they pop up on an exam paper, people say, what is this again? Oh, this go again, and they get it wrong. Or they're trying to guess through it. I don't want anybody guessing in an exam. So we need to remember these things. So these are like our special functions, questions that we want to pay attention to. All right? All right. And I cannot give you an idea of how frequently they set. Some of them, they hardly ever set them. Hardly. Some of them, they set it a little bit more frequently than others. We're preparing for an exam now. So, you know, if we prepare for these things, we're actually doing this class about preparing for an exam. All right. So I have to tell you exactly how it goes. You know, that these things, they don't set very often. So you're going to make a little notes today and put those notes in a special place. So when you're revising functions, you don't forget them. Because if you depend on just doing past paper questions as your means of revision of function, you're not going to see these questions a lot. All right? So let's go. And I do them one topic, do them as like a section at a time. All right? All right, so the first one is this thing now. Using the inverse function to solve the equation. The inverse of a function can be used to solve an equation that is derived from the original function. Let's put it that way. And this is using the inverse function to solve an equation. That's the first one that they don't set very often. They set this maybe like 5 times in the last 20 years, where they ask you to use the inverse function to solve it. In fact, even less than that, maybe 2 times or 3 times in the last 20 years, between the January exam and the June exam, they set a question asking you to use this thing. All right? And basically, this based on this rule that you need to know. You need to know this rule. So this is a must-know item. This thing is a must-know. Let me write it. You must know this rule. Must know. That's a rule that you must know. This I'm talking about this down here. That is the premise on which we're going to solve these questions. Very easy thing to remember. If f of x equals some number, then x equals f to the minus 1 of that number. So look on the right side now. So for example, if a function of x is equal to 3, right? And that's an equation, a function of x is equal to 3. It means that x is equal to f to the minus 1 of 3, provided that it is a one-to-one function. A one-to-one function. And when they give this question, they will always give it to you with a one-to-one function. They'll always give it to you with a one-to-one function. For another function, for example, some function g of x equals -7. Simple. It means that x equals g to the minus 1 of -7. So that if some other function k of x equals 10, it means that x is equal to k to the minus 1 of 10. And it's something that I want you to use. So that is it. If f of x equals a number, then x equals f to the minus 1 of a number. What it is really is that we are saying if x is mapped onto n with f, then the n is mapped back onto x with f to the minus 1. Because remember, that's what f to the minus 1 does. It reverses the mapping. It reverses the mapping. All right? So essentially, that's the inner workings of it. Right? If x, some unknown value x is mapped onto a value n by the function f, then the inverse function will map the n back onto that unknown value x. That is it. That is the concept of it.
Sir, I have a question.
Yes.
Where it says rule for any one-to-one function. Does it mean strictly that this can only be used for one-to-one functions? Eh?
Yes, because remember we said only a one-to-one function can have an inverse. Only a
Okay.
one-to-one function can have an inverse. Remember I said that last week? Only a one-to-one function can have an inverse function. Many-to-one functions can't have no inverse. Because if you reverse a many-to-one, it becomes a one-to-many. And a one-to-many is not a function. Remember that? That's
Yes,
what we
sir.
said last week, right? So this rule relates to one-to-one functions. And they won't give you a many-to-one function question, a many-to-one to do it with. They will give you, if they're asking you to do this, they're going to give you a function that is one-to-one. All right? But it's good to know that only a one-to-one function can have an inverse. And therefore, because we are using inverse function here, it means that it has to be a function that has an inverse. And only a one-to-one function can have an inverse. Make sense? Make sense? Because if
Yes,
you're going to
sir.
be using the inverse function, then it has to be the case where it is a one-to-one function, because only a one-to-one function can have an inverse. All right. Good question. All right, let's move on now. So we can just basically do it now with some examples. All right, this is something else. If f to the minus 1 of f equal, if f to the minus 1 of f of x equals x, then f to the minus 1 of f of x will equal to x every time. All right, because what really happens is that if you transpose f to the minus 1, it becomes f of x equals f of x. All right, but don't worry about this too much. Right, it's something that you can work out if you have to. But f to the minus 1 of f of x will always be equal back to x, because it's almost like you're reversing a mapping. So like you do this mapping and then you're reversing it with the f to the minus 1. So you must go back to x. All right. So like you do a mapping and you're reversing it at the same time. All right. So you must go back to x. So that is another rule. But this is what we're focusing on up here, though, the top one. This is what we're focusing on. All right. Don't worry about the second part here. Right. No. That's what we're focusing on. All right. So we're gonna do examples with it now. All right. So let's do this example. I'm deliberately put back a rational function there because I want us to practice the transposition of the rational function. All right. So I put back a rational function right here. So let me show you something with this question before I go to that. Now, this question is saying that given that f of x is equal to this, they want us to find f to the minus 1, and hence the keyword here, hence. The hence means that we have to use this thing that we just found to solve this equation. All right, so it's telling us that we must use the inverse function. It asks us for the inverse function, right here, and then it says hence. Hence means we must use what them just asked us for, which is the inverse function. So essentially, that's what they're telling us to do here. Use the inverse function to solve this equation. So let me break it down and show what is happening now. Which is quite easy. What you must realize is that what we have right here, this really is f of x. So what we're really solving right here is f of x equals 3. That's what we're really solving, Because that thing right there that I've circled really is f of x here. Is f of x. So we're really solving f of x equals 3. And what we just said, if f of x equals 3, then the x that we want is f to the minus 1 of 3. All right? That's what we're basically doing, So show you one more thing. When the question says solve this, you see what question says solve this? It means that you have to find the value of x that satisfies that equation. That's what solve means. Solve means find the x value that will cause this thing to be equal to 3. Find x value that satisfies that equation. That's what the word solve means. So it's really x we're trying to find. All right, so let me go back. This is really f of x equals 3, and it's x we want. If f of x equals 3, the x that we want is equal to f to the minus 1 of 3. All right, so basically that's what we're doing. So let me do it over here, though. Let me do it over here and show you. Let's go through the steps, because as I said, I deliberately choose a rational function so that we can get some more practice with this rational function, transposing. So let me do this one right here. And I deliberately chose this as a rational function. So I'm going to put this on the screen and I'll work it out. All right, into screen, and then we're gonna get a piece of history quick. Let's maximize it. All right, so we're doing this question right here now. All right, ready. So we're gonna find f to the minus 1 first, and then we're gonna solve the equation. All right, so let's go through the steps again. More maths equals better maths. So let's go. All right, so we're starting with the f as usual. All right, so we're gonna say f equals 4x plus 5 divided by x plus 2. That's our function. We're gonna inverse it. Bam. When we inverse it, the f becomes x, and the x becomes f to the minus 1. So we get 4 f to the minus 1 plus 5, and we also get f to the minus 1 plus 2. And as usual, we're trying to transpose to make these a subject, right? Same procedure. What did we say? This as one thing and multiply across here by the x. That's our first step. Trying to make f to the minus 1 the subject. So it becomes x times f to the minus 1 plus 2x. That is the x times this and the x times that. Gives us that first. And then on the right side, we get back this numerator, which is 4f to the minus 1 plus 5. All right, then we need this over onto this side, and we need this over onto that side. All right, that is the procedure. So we're going to get f to the minus 1 minus the 4f to the minus 1. By the time we get that, when this come over this side, it becomes negative. All right, and then equal, this is a plus 5 over there, so it comes back as a 5. And then this now comes over here and becomes negative 2x. All right, becomes negative 2x when we transpose it. So far, so good. So far, so good. Remember, if you don't understand something, just tell me. So if I don't hear anything, it means that everybody good. All right, I can't read the minds, guys. So if you don't understand something, just let me know. It's not a problem. If I have to stop and explain something, it's not a problem. Don't feel like you're bothering me if you're stopping me to explain something. All right, we're going to factorize the f to the minus 1 now. So factorize the f to the minus 1 bracket, and then it's x and minus 4 in the bracket. So it's x minus 4 factorize out f to the minus 1. And this means 5 minus 2x. As usual, now take all of this and divide under here. See, there's a few steps, you just need to practice it, guys. And so we end up with f to the minus 1 equals 5 minus 2x divided by x minus 4. And that is our f to the minus 1 of x. So we can put it back now, f to the minus 1 of x. So we know that f to the minus 1 of x is equal to 5 minus 2x divided by x minus 4. That's what we know. That's the first part. So we're doing the hence here, so now, the hence now. And we're doing it on the right. So we're now doing the hence part. We're solving 4x plus 5 divided by x plus 2 equals 3. That's what we're solving. But what are we solving? So we can say, i.e., what is this really? This is really f of x equals 3 that we're solving. And if f of x equals 3, we can say that implies, based on the rule, let me write the rule down here in red for you. Let me just write it down here. If f of x equals some number, then x equals f to the minus 1 of that same number. So this is a rule that we're applying up here. So since f of x equals 3 right there, it means, this means thus or therefore, or it implies that the x that we want out of this equation, right, is equal to f to the minus 1 of 3. And this is our f to the minus 1 of x down here. This is our f to the minus 1 of x, you know. So how do we get f to the minus 1 of 3? Put the 3 in this f to the minus 1 of x. But understand that? That's what we're doing. Put the 3 in the f to the minus 1 function that was just calculated. Alright? So let me do it now. let me do it. So putting it in that f to the minus 1 function. So let me leave the red around that so we can see it. I'll draw it better. So we're really finding this. So put in this now. The same thing down there that we have in red. Right? The box down there that we have in red to get f to the minus 1. And so we can say therefore the x equals, therefore the x equals hello students. But can you
Yes,
hear
Yes,
me?
sir.
sir.
All right, sorry
Yes,
about
sir.
that. Somebody was calling my phone. Sorry about that. All right, so this is x equals, I would put in the 3 in the f in the function now. So it becomes 5 minus 2 times 3, 5 minus 2 times 3 divided by x minus the 3. No, not x minus the 3, 3 minus 4. This we're placing x here and here. All right, so it is 3 minus 4. But understand that? But understand that so far?
Yes, sir.
Good. And so the x becomes 5 minus 6 over 3 minus 4, which is negative 1. That becomes negative 1 over negative 1, which then is 1. And that is it. The x equals 1. All right. And to prove that it is true, we can put the 1 in this. And if it is true, then the answer will be 3. So let's test it down here. So if the x is 1, and that is true, then it will be 4 times 1 plus 5 divided by 1 plus 2. 4 times 1 is 4. 4 and 5 is 9. 9 over 3 is 3. So that is true. So that x is equal to 1 for real. So far, so good? What good?
Yes,
Yes,
sir.
All right, good. So this
yes,
is a
sir.
rule down here, guys. Everybody need to remember this rule. And how do we know that they wanted us to use the rule? How we know that they wanted us to use the rule was the use of the word hence. That's how we knew that they wanted us to use it, the inverse function. They wanted us to use the inverse function by saying hence. That is how we knew. Right? They didn't want us to solve it the normal way. I could have solved that equation straight in. Look, let me solve the equation straight and show you. Right? And if you do this in the exam, the question says hence, and you go and do this in the exam. If you did this, 4x plus 5 over x plus 2 equals 3. And just go and solve it normally. You're not going to get any marks because the question said hence. Hence means use what I told you to use. Use what you just found. I could solve this. I could treat this as one term and multiply across here by the 3. That's how we did. And we would get 4x plus 5. Write that properly. You would get 4x plus 5 equals 3x plus 6. If I multiply this by the 3 and multiply this by the 3, I get 3x plus 6. Right? And then if I transpose the 3x over here and transpose the 5 over there, I would get 4x minus 3x equals 6 minus 5. So we get x equals 1. We could do this, you're not getting any marks. Why? Because the question said hence. So if you get the right answer, you're not getting any marks because you would not have used the inverse function. You would not have used this rule right here. All right, the question wanted to use a rule, and that is why it said hence. Mute your mics, please. Mute your mics, please. Mute your mics, please. All right. So that is that. All right. So that's the first thing. But understand that using inverse function to solve the equation. Now this this as I said about 2 or 3 times in the last 20 years. All right. So you know it's not something you're gonna see every day. All right. So let's go back now to the PowerPoint. So the next thing we're looking at now, that's the first thing. We did an example. All right. And we might get in one to do in the class on Wednesday. All right. The next thing now that they set maybe 3 or 4 times as well in the last 20 years is when a function is undefined. What do they mean by that? What is the value of x that will make a function undefined? Now, undefined means it's a value that we don't know what it is. We don't know the size or the magnitude. We don't know what it means. And we're not talking about zero, because everybody knows what zero means. Zero means none, nothing. So if you say 0 apples, it means that there are no apples there. Everybody know what 1 means. 1 means 1. You count by 1. 2. Everybody knows that 2 means 2 things. Everybody understands 2, right? And everybody understands numbers up in the millions and trillions and billions. But then now sometimes you get to some values where mathematically you cannot work it out. And essentially that is when you're dividing by 0, right? That is when you're dividing by 0. So for example, if I have 1 divided by 0, 1 divided by 0 really is counting how many times I'm taking 0 from 1. So as though 6 divided by 2, I'm counting how many times can I take 2 out of 6. The answer is 3 times. So 6 divided by 2 is 3 times, meaning I can take 2 out of 6 3 times. But how many times can you take 0 out of 1? If you take 0 out of 1, you still have the 1 left. If you take 0 out of it again, you still have the 1 left. If you take 0 out of it again, you still have the 1. If you take 0 out of it again, so no matter how many times you take 0 out of 1, the 1 will still be there. So the number of times that you can take 0 from 1 is an infinite number of times. And that go for any number divided by 0 is what we call infinity, which is undefined. This is a symbol for infinity. It's undefined. So a fraction is undefined when the denominator equals 0. So this function, we're talking about a function is undefined or not defined. It's basically when your denominator of your function is 0. And so this happens when the function is a fraction function, a rational function. All right? So that is what is happening. So remember now, it is when your denominator equals 0. All right, as simple as that. Or what value of x will make your denominator be 0? That's how you know. Why am I not able to clear this now? So I cannot take this thing. This thing always doing it whole thing, its own thing. Let me try again. Oh Lord. Let's try it this way. All right. Right. So let me go back. All right. So we say it's when your denominator equals 0. All right. So when a function is undefined or not defined. So we say a rational function is a fraction, is defined, meaning it has no real result when the expression in the denominator is equal to 0. So any value of x that will cause the denominator to be 0 will cause the function now to be undefined. That's how it works. So this is because a number cannot be divided by 0, as I just explained. And if you have a calculator, you just try it there now, or even your phones. You just try to divide by 0, you're going to get some kind of error message, syntax error or some kind of error message. All right, some undefined message that you cannot give you a value, cannot give you an answer. All right, so for example, find the value of x for which this function, this rational function is undefined. So it's basically what value of x will cause the denominator to be 0. Anybody can look at it and tell me what value of x will cause that denominator to be 0?
So -2.
Very good. So that function is undefined when the x is equal to -2. But a way to actually calculate it is just to equate the denominator to 0 like that and let the mathematics work it out. So f of x is undefined when the x plus 2 is 0. And if you solve it, you see that is when the x equals -2. So as that person just did, you can actually look at it and know. But if you're not certain, you can just put the denominator equals 0 and solve it. All right, so it's pretty simple and straightforward. So look at the right side here. Let us write another example quickly. Say g of x equals 5x plus 1 over 3x minus 2, right? We can say g of x is undefined or not defined when the 3x minus 2 becomes equal to 0. And if you transpose this, here over the 2 first become +2 and then divide under the 3. Right? So that is when the x equals 2/3. X equals 2/3. All right? That is if it is undefined. If them says 0 now, g of x is 0. G of x is 0 when the numerator is 0, because if 5 plus 1 over 3x minus 2 is 0, this is a g of x, you know. This right here is a g of x. All right? So if the g of x is 0, if you multiply this as a block over by the 0, it's going to become 0. All right? And so you're gonna be left with 5 plus 1 equals 0. So that is when the numerator is 0 now. So a function is 0, a rational function is 0 when the numerator is 0. A rational function is undefined when the denominator is 0. Remember, undefined does not mean 0. That's a mistake a lot of people make. A lot of people believe undefined means 0. 0 is a quantity that we can define. We know we can define. We know what 0 means. 0 means nothing. So it is a quantity that we know what it means. So we can define it. It means nothing. So when we say undefined, we're not talking about 0. So this is not saying g of x equals 0, the undefined. Undefined means infinity, infinitely large. So large we cannot say what it is. That's what undefined means. And generally speaking, a fraction becomes undefined when the denominator is 0. But that same fraction equals 0 when the numerator is 0. All right, so I'm not going to say anything more about that. So we did these 2 examples, that is it. So in this case, the x would be equal to -1/5 when the g of x, this is when g of x is 0. But for the undefined part, this is the undefined part. The x would be 2/3. All right, and this topic is about the undefined. All right, so you have to answer this for me on Wednesday as well. All right, we're not doing any more examples on this. Moving on. So far, so good. So we did inverse function to solve the equation, and we said f of x equals a number, then x equals f to the -1 of the number. And then we said a function is undefined when the denominator is 0. A rational function is not defined when the denominator equals 0. Right? And a function is 0 when the numerator is 0. All right. So let's move on now. Hope you're making notes. Moving on. The next thing now is this thing now that they said twice in the last 20 years, or last 25 years, maybe more. One time on a January paper and one time on a June paper. Believe me. What is this about? This now is about reversing the process of forming the composite function. So we looked at how we form composite function earlier. We'll put one function into the next. Now we're looking at, they give us a composite function and we have to break it into 2 simple functions. That's what this topic is about. Deriving 2 functions. You can put in the word simple right here if you want. Deriving 2 simple functions. 2 simple right here. 2 simple functions from a composite function. How do we do that? They said this twice in the last 20 years. Once on a January paper and once on a June paper. I'm telling you, they don't set this very often. But you don't know what's coming on your exam next year. So you have to prepare for it. And it's very simple. We are doing the opposite of what we do when we form the composite function. That's what we're doing. And it's a 3 steps process or a 2 steps process. Nice and easy. Let's look at the steps. First step, find the inner function first. Let the inner function be equal to the expression within. I'll explain what I mean by the expression within just now. All right, but that's the first step. Let the inner function be equal to the expression within. All right, so we're going to find the inner function first. Next thing, reverse the inner function with x. And if we reverse the inner function with x, the result is the outer function. The result is the outer function. Well, let me ask you something before we move on. If I write f of g of x as a composite function, which one of those two functions, the f of the g, the f or the g, which of them am I referring to as the inner function? Which of them?
G.
The g, exactly. The g is what I mean by the inner function. So if you want to break a composite function, which is f of g, you find the inner one first. That's what I mean by the inner function. That is the inner one. Find that one first. All right, let's talk about the expression within now. Now, if the expression I have is 2 into x plus 5 squared minus 7, what there you believe is the expression within? What will be the expression within? What do you think I mean by the expression within? If that is my overall expression, which part of that becomes my expression within? That's common sense. Tell me. Somebody tell me.
X plus 5.
The x plus 5. Simple, it is within the bracket. It is the expression within. So all I'm saying, if this was my f of g, and I want to find the f and the g, I find this first. I make my g be equal to the expression within first. That's what I do. Then what I do next? I take out the expression within, which is the g, and replace it with x. So let me set it up with this very example for you so we can see it. So see it here, if them tell me that f of g of x equals 2 bracket x plus 5 squared minus 7, and I want to write what g of x is and I want to write what f of x is. Simple. All I do, let me use the red ink to show you. I take this and I put it equal to the expression within. All right? I put it equal to the expression within. I'm going to take it out. And then what I'm going to do after that, I'm going to take a x and bring back a x back in there, and also put back a x back in there. Simple as that. So I take out the f of g, the g of x, sorry, and the expression within. I take them out. I put them equal to each other and I take them out. Take out those two. And then I replace them with x. All right? So let's show you what's going to happen now. When I take out the expression within, I'm going to get that the g of x equals x plus 5. And if I take them out and I replace the g with x on the left side, I'm going to be left with f of x now on the left side. Because where the g was right here, I'm now putting x there. And that is going to be equal to 2 times. Now, because I take out x plus 5 and I'm putting x in its place, I put back the x, and I put back the square up here, minus 7. You understand that? Simple. Take out the inner function and replace it with x. Simple as that. So the first step is to let the inner function be the expression within. Take out the inner function.
Sir, can you go back over?
Go back over it one more time.
Yes, sir. Please.
Yeah, let's start it. Yeah, man, no problem. No problem. I'm going to use the same slide. I'll show you again. All right. So all I'm saying, I want to break that function into 2 simple functions. So I'm reversing what I do when I form a composite function. I'm doing the opposite. When forming a composite function, we take a whole function and put it in another function. Now we're doing the opposite way. And when we put it in another function, what we do? We replace a x. That's what we do when we form a composite function now. We take a whole function and we replace a x with it. We're doing the reverse now. We're taking out a whole function now and we're putting in back the x. That is what we're doing now. We're going the opposite way now to what we did when we formed the composite function. But the steps is to make it nice and clean and to make it, flow nicely. We find the inner function first, because remember, when we're forming the composite function, it is really the inner function we're moving, because we put the inner function into the outer function. So it's always the inner function that is doing the movement, or we're forming a composite function, It is the inner function we always move and put it in an outer function. So we do the reverse now. We're going to move the inner function out now. We're going to move the inner function out and put back x in its place, because we're reversing the process, basically. If you think about how you form a composite function and you're doing the reverse process, right? So what it is, right? Hold it. Oh, so I have to do it over. No problem. I have to do it over. So let me do it again. So what I'm saying, let me do it over from scratch. What I'm saying, the first step is let the inner function, which is this, be equal to the expression within, which is this. That's what we're gonna do first. So see it there. Let g of x be equal to the x plus 5. That's just step 1. Now what to do next? Step 2. After you take it out, you're gonna put x in its place right here and put x in the place right there. Place them with x. And what you have is the outer function. So after we take it out, we're gonna say therefore, after we replace it with x, we're gonna end up with f of x. Because where the g was, where the g of x was, we now put x there. And on the right side, we put back the 2. Where the x plus 5 was, we now put x there. Put back the square on it. If you want to bracket it, no problem, Because that's what it will be, If you want to bracket it, just make sure, But x in a bracket don't make no difference. Right? We can just leave it as just x squared. And then put back the minus 7. Understand it? Looking all right? But
Yes,
understand
sir.
that? Simple as that. First step is important. Let the inner function be the expression within. Let the inner function be equal to the expression within. Find the inner function first. It is the inner function that is always moving. When we're forming the composite function, we move the inner function into the outer function. Now that we are breaking the composite function, we take the inner function out of the composite function and then we'll put back x in its place. We are reversing the process. They don't say this very often, They said it twice. But we don't know if you want to come on our exam paper. So we're preparing for them if they set it. And a question like this, because I only set it twice, chances are going to do 30 past papers and never see this question. You do 30 past papers and don't see this particular question, a question asking you to do this. Just me. Okay, I might just not pick up those 2 exam papers that I said, because they said them long ago. But they're on the syllabus, so they can come back anytime. You have to prepare for it. All right? And so you're getting another one in the classwork on Wednesday. So that is how it is done. Find the inner function first. Take out the inner function with the expression within. Let the inner function be equal to the expression within. You replace the 2 of them with x. And what you have left is the outer function. And that is it. And you can test it, because look here now. Look here how you can test it now. Suppose I were to use these 2 to reform my composite function. Let me use a blue ink or a green ink and show you. Just forget about what we had before. Let's say I'm starting back right here. Right? And I want to form I want to form back my composite function. So sometimes you finish, you can test and see if it will work, you know. If I were to reform the f of g of x, remember f of g of x means g into f, you know. How do we do it? We'll take all of g, don't it? And we'll bring it and put it into the f right here. That's what we would do, you know. And what would be our result when we do that? Our result would have been 2, where the x is, we would have put the x plus 5. We'd have to write back the square and put back -7. So you see, we'll be getting back that thing up there anyway. So sometimes what you can do a little check to make sure that if I were to reform that composite function with the 2 simple functions that I've found, would it work? And the answer is yes in this case. It would work if I were to go and reform the composite function. All right? Sounding good? Just need to practice. All right? When you come to class, guys, come to class because you want to learn new things. That's why we come to class. So don't feel any way when you see something brand new and different. Because I'm certain that you've never seen this before. Certain of it. Right? But it's new, right? It's just new to you. But it's very easy. And you just need to practice a couple of them. All right? Write some functions, break some composite functions and reform them. Break some composite functions and reform them until it becomes like second nature. Able to form composite functions, and you're also able to break composite functions. They don't normally ask you to break composite functions, but if they do, you still want to be able to do it. The most they ask you to form composite functions, but we want to be able to break composite functions as well, just as good as we can form the composite functions. All right, so let us not forget about this one. All right, and if you look back at the examples at the slide now, let's get back to the slide. All right, that's the example that I have on the slide. So looking at that, all right, let me make it a little bigger so we can see it. All right, looking at this example, remember, form the inner function first. In this case, the inner function would be the g. All right, so let me write it over here. All right, in this case, the inner function would be the g. So we would, let me do it on the right side. So we'll see. Let me do it on the right side. All right. I don't want to change the approach. So we have, as another example, we have f of g of x equals 3 into x plus 2 squared. Easy. What did we say? Let the inner function be equal to the expression within. So we're going to let this inner function be equal to the expression within here. I'll write that first. G of x equals x plus 2. What we do next? Put x in its place right here, and put x in its place right there. Place the inner function with x, and the result, f of x, is the outer function. With x plus 2 was I have x there now, and there was a square. If you want to put the bracket and then put the square, no problem for now, but it don't look right because you don't need any bracket there. That is it. All right, so don't worry about the steps shown here. A little bit more complicated that I've just showed it, but that is the final result. It's just that you just kind of write them down. You don't need to write this step that I'm putting on the slide here now. You don't need to show that step. You can just write this and then write that. It's easy. All right, let's look at another example. This is an exam. I think this was the actual one of the exam questions that they set. Right? This came off an exam paper. So it's one of the 2 examples that I said. I think this one came on a June paper years ago. But I say h of x equals 5 over 2 bracket 2x plus 1. All right, model this one off an exam paper that they said. And they say it is a composite function. They tell us it's a composite function. And they tell us to derive 2 functions, f and g, such that h of x that they gave us is actually a composite function, f of g. So what they're basically saying is that instead of h, we could have written this as f of g of x. That's what it is. Let me do it over on the right side here. Right? So we can see it build up rather than to look at the slides. Let me do it over here so we can see it. So we have h of x equals 5 over 2 into 2x plus 1 cubed. All right, and they're telling us that the h of x is really f of g. So we can say that is f of g of x is 5 over 2 bracket 2x plus 1 cubed. All right, so talk to me now, guys. Talk to me. Unmute the mic and talk. All right, so we said first thing is to let the inner function be the expression within. Let's just write them down. It's easy. So the inner function is what? The f or the g?
G, sir.
Good. So it's a g of x. Good. So it's a g. So we're going to write the g of x first. So g of x equal expression within. What over there now is the expression within? Tell me.
2x plus 1.
2x plus 1.
Very good. 2x plus 1. All right. Just imagine now, we take out the 2x plus 1 and replace it with x. So we're going to write now the f of x now. So the f of x is therefore equal to what? What is it equal to? Tell me. Talk to me now.
5 over 2x cubed.
But I get that. That is it. That is correct. That's how easy it is. Nice and easy. But I get that. If somebody don't agree or somebody don't understand, let me know. All right, good. So if somebody don't understand, let me know. Don't let me move on and you don't understand. So everybody understand that?
Yes, sir. No.
All right, good and easy. All right, let me give you a look. But understand that? But all right?
No, sir.
You don't understand it? All right, let me show you step by step then. All right, what we did, just look at it again. It's almost like we're just moving things around. What we did, let me erase this and show you what we did again, step by step. All right, you have to remember the steps, you know. The first step is important. Let the inner function be equal to the expression within. So you have to know what the inner function is. You have to know what the expression within is. And you can look at it and see it. The inner function is this one. Because we define this on the first day we started functions. That is the inner function. And you're going to let that inner function be equal to the expression that is within. This is the expression within. It is as it says. It is within a bracket. It is within something. Put it equal to the expression within. All right? Because we're trying to form two simple functions. Sometimes not the only two simple functions we can form, because somebody might decide to make their inner function, the expression within, be the 2x plus 1 r cubed. You know. You still get two functions that will work. But we are true, that is the obvious expression within right here in this example. So that is it. First step is to let the g of x, the inner function, be equal to the expression within, which is a 2x plus 1. Now imagine now. Just imagine now. I'm going to use a blue ink for the f now. We're going to replace this with the x. Put back x in this place here, so. And put back x in the place here, so as well. That's what we're doing. So putting back x where the g of x was, I'll putting back x where the 2x plus 1 was. So when we put back x there, we're gonna get f of x. So where the g of x was right there, we're putting back of x there, equals, and then where the 2x plus 1 is on the right side, we're putting x in its place. So we're gonna get 5 over 2, where the 2x plus 1 was, I'm putting x there now, and then I put back the cube on there. You see it now? Any better?
Yes, sir.
Simple as that. All you need to do, guys, is go and just work it. Put pen to paper and work it yourself. It's very easy, believe me. And it becomes even easier when you start to put pen to paper and work it yourself. All right? Well, let me give you one little one now. Let me see who thinking. All right? Let's say h of k of x was equal to 3 over x minus 4. I want to break that onto h of x and k of x. H of x and k of x. Remember now, the first step is let the inner function be equal to the expression within. Somebody tell me now, which of these, the h or the k, which of them is the inner function?
K, sir.
Okay.
All right.
K.
Good. All right. Over on the right hand side now, if you have the 3 over the x plus x minus 4 there, what would you choose as your expression within?
X, sir.
The X?
Yes,
Can't be
Yes,
the
sir.
X. Can't be the X. Because if you move a X and replace back a X, you're getting back the same exact thing. Can't be the X. Come again. What would you choose as your expression within? It will have to be the entire denominator x minus 4. That is what you have to write as expression with, and I can show you why that is so. Show you why that is so. Watch me. See this 3 over x minus 4 is the same as 3 times x minus 4 to the negative 1, believe it or not. It's the same as that. So you see, it is still expression within. See that? It's the same thing that you know. This and this is the same thing. I'm not going to go into explaining right now why it is the same thing, but they are the same thing. So this x minus 4 is still your expression within. Right? So let's look at it and see how it would work. And you see that you're correct. Watch this. I see that we are correct. Watch this. So let the inner function equal to the expression within all of this. Now what we're going to do next? Let's write it first. So our k of x, putting it as x minus 4. What do we do next? Let's use the purple this time. What do we do next? We're going to replace this inner function with x, and also replace this inner function, this expression within with x. And then our outer function h of x is just going to be 3 over x. Simple as that. And if you think about it, again, as if to say, we are using these two to reform h of k of x. How would we do that? This would mean, remember now, that this would mean k into h. So it would mean this k into this h right here. And you will get back the 3 over x minus 4. If we were to reform the h of k. Mute the mic, please. Mute the mic, please. See that? That's what you would get. All right, but it only really need practice, guys. It only need practice. So a few examples that I did on the slide today, or in the class today, I want you to go and practice them yourself. Go and practice them yourself. All right, it's very easy. All right, just need a couple of practice. And soon, trust me, by the time you get to Wednesday, you'll be writing these, you'll be working these composite functions by just writing 2 lines, quick and fast. Trust me. All right. So can I move on? Think we can move on?
Yes, sir.
Yes, sir.
All right, good. So this was the example. Let's keep it simple. That is it, all right? Next thing now, inverse of a composite function. Now, this is a one. So even though they don't set it every year, like what we did last week, this is the one that they set the most out of all that we're doing today. And one of the reasons why they set it the most is because they actually have 2 ways of setting this. All right? They actually have 2 ways of setting this thing. All right? Someone needs to mute the mic. Right. So of all that we did today, this is the one now that they set the most. All right. So so you're more likely to see this one of all that we did today. You're more likely to see this one. This inverse of a composite function thing. All right. And it's based on a relationship that you have to see and know and understand. So let me bring back a screen to write on. Put it over here so we can write on it. We're going to do some examples. All right, inverse of a composite function. So we have inverse of simple functions, like we have f and we have f to the minus 1. And we have g and we have g to the minus 1. Now we're talking about the inverse of f of g, or the inverse of g of f. And it comes down to a rule that you have to pay attention to the details and know and understand. Right? And it's a rule that we'll have to use, and it's a rule that we'll have to also prove. There are questions where we have to prove the rule, and there are questions where we have to use the rule. All right, I'm going to do an example where we are proving the rule, which is more work, and we're going to do an example where we are using the rule. When you have to prove the rule, they will show you the rule. But when we have to use the rule, they won't show you the rule. You have to know it in your head. So you have to know the rule in your head as well. And that is the rule right there, simple. So this is a must-know item. This every student must know this. So if you study and know this, and look at the details of it. The composite function is inside here, f of g. And we're doing the inverse of that whole composite function. That's why they have the bracket around here. We're doing the inverse of that whole composite function on the left side. All right? And what we're saying on the right side, it is equal to the composite of these two inverses. But if you notice, when the g is second in here, it comes first out here. If the f is first here, it becomes second out there. All right? So you have to pay attention to that detail. Pay attention to that detail, guys. So the inverse of the composite function, f of g, is equal to the composite g to the minus 1 of f to the minus 1. The inverse of the whole composite function, f of g, is equal to the composite function g to the minus 1 of f to the minus 1. Pay attention to the details. See how we say it in words here. This is how we say it in words right here. The inverse of the composite function f of g is equal to the composite g to the minus 1 of f to the minus 1. Again, note that in the composite, f first, g second. So this is g into f, you know. Inverse of that composite, g into f, is equal to the composite f to the minus 1 into g to the minus 1. So the turn around somewhat. All right, pay attention to that detail first. So let us write a couple so we can see that we get that part first before we move on. And this is basically the same thing. This down here is the same thing. Really is that now I'm showing it with the of x. So sometimes they show it like this up here, and sometimes they put in a little of x right here. But it's the same thing really. This and this up here is the same thing. All right, it is the same thing. All right, so don't make that show you up. So I could do a couple things now. So talk to me now. H of k. Let's do a couple more. And you tell me what they equal to. H of k r to the minus 1 equals what? Talk to me. What it equal? H of k r to the minus 1 equals what? Open your mic and tell me, guys. H of k.
K to the minus 1 and h to the minus
Don't
1.
say and. No, not and. It's k to the minus 1 off h to the minus 1. That's what it is. K to the minus 1 off h to the minus 1. That's what it is. K to the minus 1 off h to the minus 1. But understand that? Let's do another one. R of s, r to the minus 1 equals what? What equal? Get this part first, right first. What equal?
Sir, s to the minus 1 of r to the minus 1.
F to the minus 1 of r to the minus 1. Very good. And P of Q, all to the minus 1. P and Q are functions. Equals what? What equal?
Q to the minus r of p to the minus 1.
Of P to the minus 1. Very good. And G of F, all to the minus 1 is equal to what?
F to the minus 1 of g to
F
the
to the minus 1 of G to the minus 1. Very good. All right. So establish that. Now let's talk about something else now. Let's talk about something else now. So we have that thing right there, for example. Let's work with this one right here. G to the minus 1 of F to the minus 1. All right. let me write about the other one that we have on the slide. So we can, so work with the one that we have on the slide, which is f of g r to the minus 1 equals g to the minus 1 of f to the minus 1. So what I want is for somebody to tell me what that one means. How would we find that? So we were to work that out. How would we find that? The left side. Somebody tell me how they think would work out f of g all to the minus 1. What would be the steps to find f? If you know what f was and you know what g was, how would you find f of g all to the minus 1? I want to know if you know what it means. Somebody
Sure.
tell me. Anybody? Yes?
Would you find the inverse of each and then times them by each other?
Nope. Nope.
Um,
Think again.
would you, sir?
Just the left side alone, not the right side. Just the left side. Tell me how you work out the left side. If you know the f, like suppose them say f equals 2x plus 5, and them say g equals 7x minus 8. Two functions, f and g, and them tell us you must find f of g all to the minus 1 like that. What would be the steps in finding the left side? F of g all to the minus 1. I just want to know what you're thinking. Come on,
Sir,
somebody.
you find the inverse for both?
No, I just want to find the left side alone.
Just you calculate them together and then you find inverse?
Basically, calculate them together, what you mean?
As in like you put g into f and then
Good.
Yes.
Good. Nice. You'll find the f of g first. And then after you find the f of g, you just inverse that f of g where you find. See that? You'll find the f of g in yourself first. And after you know what f of g is, you just inverse that now the normal way. And that will give you the whole thing. Very good. So that is how we'll get the left side. But understand that what I just said? Now remember, when you don't say the right thing, it's not a problem, guys. Because remember, we're learning, And we want to see how the thought process going, and at least you know that, okay, you're not on the right track, and you know what the right track is now. So not saying the wrong thing, I don't want anybody to feel that way. When me used to go to school, me used to say whole of wrong things. Until me turn master now, pure right things, me I say. You understand? So don't feel that way if you don't say the right thing. I want people to talk up, let me know what to expect. Sometimes when you say the wrong thing, it give me the power and give me the latitude, and it let me know what I need to say to you to explain it better. So don't be afraid to say the wrong things in the class, guys. All right? We're learning here. We're learning. We're building. We're going nice and slow, and we're doing patiently. So tell me now. So let me just explain the left side again. If we're going to work out the left side and work out what the left side equal to, assuming that we know what the f is, and we know what the g is. If we wanted to work out the left side, which is on this side right here, and we want to work out what that expression is, we'd have to composite them first. Do the f of g first by putting the g into the f and work it out and simplify it down. And then after we work it out, they would have to inverse that whole thing that we will get. And that's how we get the left side. All right. So talk to me now, guys. You again. Anybody. And people are not here. I want to hear from everybody, It's not the same person who must answer the questions all the time, But if some people not saying anything, then the same people will answering all the time. So I want to hear from everybody. I'm not hearing from the girls today. So come on, I want to hear from everybody, boys and girls. Everybody, talk up. Get involved. Suppose I want to work out the right side now. What will be the steps to working out the right side? If I know the G and I know the F, how would I work out that composite now? G to the minus 1 of F to the minus 1. What would be my steps? What would I have to do to go step by step to work out the right side, what the right side equal to? Somebody talk to me. Let me hear. I don't care if it's right or it's wrong. That is not important. Talk to me. Let me hear. Somebody chime in and talk. Come on. If you wanted to work on the right side, what would you do? Tell me what you would do. Somebody. Nobody can talk. All right, the people who want to talk already, talk. Don't be afraid to talk. Let me hear.
Sir,
Yeah.
you find the inverse for each of them, sir.
Yes. And then?
And then you would multiply them by each other.
No. Remember, g to the minus 1 of f to the minus 1 don't mean multiply, no, guys. It means 1 into the next. That's what it always means. Don't mean multiply. So when you see g and f beside each other, remember, I know if you say g and f beside each other, it means f into g. So if you say g to the minus 1 and f to the minus 1 beside each other, it means f to the minus 1 into g to the minus 1. Just the same. You understand? So remember, you don't multiply them when you're forming a composite. Composite means one function into another function. That's what it means. The composite. That's a composite, you know. That's a composite of g to the minus 1 of f to the minus 1. So it means f to the minus 1 into the g to the minus 1. So your first step correct. So we're learning, you know. So when we bring that to, so we're supposed to multiply. Now we know we're not supposed to multiply. And I know maybe there are some other students in the class thinking the same thing. And that's why we have to speak up. Because persons learn from each other's mistakes. So whosoever was thinking that is multiply as well, no, that is not multiply. And maybe I would not know that somebody was thinking multiply to say no, you must never multiply. You understand? That's why I need you to speak up so I can say no and get that out of your brain altogether and clarify it. That's why I need the people to speak up. So I thank you for saying that. Because it gives me up. I was not thinking that anybody was thinking that is multiply, but now I know I will get to clear up that misconception. That's why students need to talk up in the class so the teacher can clarify things and explain things and dispel the wrong things, and so that we can all go on the right path, right, to getting these things right, right? So we don't multiply them. So you said the right thing. Find the g to the minus 1 and find the f to the minus 1, and you composite them by putting the f to the minus 1 into the g to the minus 1. And what I'm saying that when you work out the left side, whatever you get in terms of the x, you'll get the same thing on the right side in terms of x. That's what this rule means. They will be equal to the same thing. All right, and we're going to do it with an example, because the proof of the pudding is in the eating. Right, so we're gonna do it with an example, guy. I'm gonna do 2 examples. One where we have to use the rule, and one where we have to prove the rule. I'll show the difference. To prove the rule one, when you're proving the rule, is more steps. You have to work out everything. When you're using the rule, is always a hence thing. So they ask you to find something, and I'm saying hence. And to use the hence now, you have to know this over here. You have to know this thing over here. You have to know it and use it. Right? So the question, for example, the hence method, they ask you to find this, and they ask you to find this. And the question will then say, hence, find this. Hence means that you're going to find this by using these two. So you don't have to go working out this all by itself. But that is in the use the rule questions, you know. In the prove the rule question, we'll tell you to prove that this side equals this side. What you have to do in the prove the rule now, you have to work out what all of this equal to and put it on one side. And then work out what all of this equal to and show that them equal the same thing. Show that them equal to the same thing. That is how you prove the rule. All right, enough talking. Let us do it now. Let us do it. So we have to speak the maths and then do the maths. So when you can understand the speaking of the maths, then the doing sometimes becomes easier. All right, so see an example there. That's a prove the rule example. Type 1 question. The 2 is a set question on this. One way where you're proving the rule. The other way is when you're using the rule. So, right? Using the rule. Prove the rule and use the rule. All right, so for the time being, see there, so the rule here. So in this example, they actually show you the rule that they want. So you say, given that f of x is 3x minus 5 and g of x is 2x plus 1, show that or prove that f of g all to the minus 1 is equal to g to the minus 1 of f to the minus 1. So we have to work out everything. All right, so what I'm going to do, I'm going to take a picture of this, and then we just do it on a screen, right? Let's do it on a screen. All right, and students, when you go home, I want you to go and work it over by yourself. All right, I want you to work it over by yourself. So let me Let me just put it beside it so that we have less space. Let me just write what we're trying to do. So we're trying to prove that this is f g r to the minus 1 equals g to the minus 1 of f to the minus 1. We're trying to prove that, right? Prove. Given that, prove. We're trying to prove this. So I'm going to get the question and show it now. All right, let's screenshot the question so we can put it on the top of the page and let's work with it. All right, so we're trying to prove this thing. All right. All righty. So let me get that thing to work with now. Where is it? Come on. All right. Let's maximize this. Good. So we're gonna prove it now. There's plenty of steps. There's no shortcut. Because I say we're proving a rule. We have to work out everything. We have to work out the f of g to the minus 1, or we have to work out the g to the minus 1 of the f to the minus 1. So it's that long process, no shortcut. All right. So ready now, guys. Ready. So the first thing we want to do is the left side. So we're gonna want to work out the f of g r to the minus 1 first. Left side. We want to work out the left side first. All right, that's what we're working out first. F of g r to the minus 1. Let's work it out. So to find f of g r to the minus 1, we need to work out f of g first. So we're gonna say f of g is equal to what? Equal to g into f. All right, I'm not gonna go now and start do like we're just learning this from scratch now. Just imagine that we're putting the g into the f now. Let me write, we can always erase it. So the f is equal to 3x minus 5, and that is the f function, leaving out the of x, and the g equals the 2x plus 1. And the g of f is g into f, meaning I'm taking all of g, I'm bringing it and put it right there. That is g into f, what I'm doing right now. You can always erase it, right? So when I put g into f, it becomes 3 bracket 2x plus 1 minus 5. But I get that when I put g into f, and I can simplify this now. So this becomes 6x plus 3 minus 5, which then is 6x minus 2. So this is f of g, f of g. So I form f of g. So we reach the in part here, so now we know. F of g, we reach inside part there now. But I want to inverse this now to get this that I want up here. So I want to inverse that now. It's the same procedure to inverse a simple function. So I'm going to inverse it now. See it here now? Bam, I'm inversing this now. Inverse. Let me write it here. I'm inversing this now. Same procedure as we learned before. Same procedure. Inversing that now. So let me inverse that. This f of g is my range in the function. It's just that is a composite function. It becomes x. And this x becomes f of g all to the minus 1 because it's the inverse of the composite function. So it becomes 6 times fg is my function to the minus 1 minus 2. But understand that when I form the inverse function? But understand that?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Same procedure, just that I don't have a simple function
Yes,
inversing. I'm not inversing a composite function with the same steps. My f of g is my function, just that it's a composite, it becomes x. Right here. Becomes that. Right? And then my x, which is my domain, my x right here becomes the inverse, which is now that. And it's the inverse of the entire composite. That's why I have to put the bracket. It's the inverse of the entire composite. Right? So that's why I have to put the bracket right there now. And then what I do now, I'm trying to make this the subject. That's what I'm trying to do now to make that the subject. How do I make that the subject? Easy. Carry over the 2 and add it and then divide under the 6. So see it here now? Watch it. Carry over the 2. So I'm going to be left with x plus 2 divided by the 6. And that now leaves me with fg r to the minus 1. Now, but I put on the of x on it, complicated. Leave out the of x. I keep it simple like that. So I've done the left side. That is the left side. See there? That is the left side. So I work out the left side already. Right? See there, I try to prove this, you know. FG R to the minus 1 equals G to the minus 1 of F to the minus 1. Work out the side there already. I know what the side is equal to. So I know I have to show that the right side equal the same thing. So when we work out this now, it must equal the same thing down here. So, but not that. This it must equal over there. So when we work it out, the right side now. So that's, let's go now. So that is how we prove it right. I was showing that the right side equal when we just get on the left side now. So let's do it right here now. Draw a line. I'm going to draw a line and do it right here. I want everything on the screen. So let me just draw it nice and small. Right here now. I'm going to do everything right there. Ready now. So to find a composite, G to the minus 1 of F to the minus 1, I'm going to need the G to the minus 1. I'm going to need the F to the minus 1. And then after I have the two of them, I'm going to have to put the F to the minus 1 into the G to the minus 1. No shortcuts. So watch this now. Pay attention. Let's start with the G. Let's start with the G. I'm going to say, all right, the G equals 2x. In fact, you know, let me start with the F, because it doesn't really matter. Let me start with the F. So the F equals 3x minus 5. I'm going to inverse it now. Like our thing that means I'm going to inverse it, right? So I inverse it, this becomes x equals 3 f to the minus 1 minus 5. But understand that? And then more make the f to the minus 1 here, so the subject. Good. So I'm going to do that now. Carry over the 5 and add it and then divide under the 3. Same thing every time. Pay attention, guys. Pay attention. So it becomes x plus 5 and then we divide under the 3, and that leaves me now with f to the minus 1. How that so? How that look? How that look? That look right?
Yes, sir.
Good. So that is my f to the minus 1. Watch this now. I'm going to do g to the minus 1 right beside it now. G to the minus 1 right beside it. So I'm going to start by saying g equals 2x plus 1. Right? And I'm going to inverse this as well, because you see I'm trying to get the g to the minus 1 now. I need both of them. Inverse that now. So I'm going to get x equals 2 g to the minus 1 plus 1. So far so good. Let me inverse it. And then I try and make g to the minus 1 the subject now. Watch this now. To make g to the minus 1 the subject, carry over the 1 and subtract it and then divide on the 2. So this is the same thing all the time, guys. All right? So it becomes x minus 1 and then divide under the 2. And this now is g to the minus 1. So far so good. So we have my
No, sir.
eh?
No.
No.
All
right. You understand this? You understand this part? This part you understand?
That part and the other part.
You understand what you say there?
No, come there, you never hear me, sir.
Hmm?
There, you never hear me.
All right. You understand the f to the minus 1 part?
Which part? I don't understand the part of this.
This part, what I'm about now?
Yes, sir.
All right. You don't know if I form the inverse function. You weren't here last week. You just joined this week?
No.
So you don't know form inverse function. And the same thing we do the whole time. Right, we could go again. Come, no problem. We could go again. All right, let's go again. All right, remember now, you know. All right, so you understand this part already? This part, you understand this part already?
Yes, sir.
All right, good. So that is the left side we work on. We work on the left side. See here, we work on the left side already. Good. And now we're trying to work on the right side now. And show us the two sides them equal. So we're trying to work on the right side of the proof now. Good. So to work on the right side of the proof, we need the g to the minus 1. And we also need the f to the minus 1. We have to work on the two of them. And then after we work on the two of them, we put this one into this one to form that composite function. So we need to find the two of them. We need the g to the minus 1 and we need the f to the minus 1. But because the f to the minus 1 come first, right there, so we just start with that one first. And because the g to the minus 1 comes second, we just put that one right there, so second. We work on the two of them, so we'll go again. Working on the f to the minus 1 and the g to the minus 1. The same procedure that we were doing last week. Or we'll find inverse function. Interchange the domain and the range. the f becomes x, and the x becomes f to the minus 1. So see it here, come again. The f is 3x minus 5. And we're inversing the f. We're forming the inverse. We're trying to form that, which is the inverse of f. When we inverse it, right? When we inverse it, the f becomes x, and the x here becomes f to the minus 1. And we'll put back the negative 5. You understand that? We have formed the inverse. This becomes this, because this is range. It becomes domain. This domain becomes range in the inverse function, f to the minus 1. That is all. You interchange the domain and the range. All right? So the domain becomes the range, and the range becomes the domain. And we're trying to make this the subject now, the f to the minus 1. We're trying to make that the subject. We want to leave that alone by itself. How do we leave that alone by itself? You have to be able to transpose. Carry away the 5. It becomes positive 5. And then after we carry away the 5, we're going to move this 3 by dividing it down under there. That is what is going to happen. Right? 2 steps. We don't have to do this step by. We don't have to do this. Just 2 steps. We don't have to do it one at a time. Carry over the 5 first. It becomes x plus 5. You understand that? You understand that? So the 5 are gone over the side here, the equation become x plus 5. And after we do that now, we divide under the 3. Divide the 3. So, right? So the 3 come under here. And we're now left with this f to the minus 1 by itself as a subject. F to the minus 1 is the subject. So this equals f to the minus 1. So we'll find a part here already. We'll find f to the minus 1 now. We know what f to the minus 1 is. So far, so good?
Yes, sir.
All right. Then we need the g to the minus 1 now. We have the f to the minus 1. We need the g to the minus 1 now. We need that one now. So we have the f to the minus 1 already. Now we need the g to the minus 1. Same procedure of how you find inverse function. Write back the g first. G equals 2x plus 1. I'm going to inverse it. Inverse it. When I draw that arrow there right there, so it means I'm going to inverse it. That's what I look at arrow there mean. I'm inversing the function now. So the g becomes x equals 2 times. The x becomes g to the minus 1. G to the minus 1 because I'm inversing the g function. I'm going to put back the plus 1 right here. So put it back. Because all I've done, I've interchanged the domain and the range. This is range, it becomes domain. This is domain, it becomes range. Range in the inverse function, you just put the minus 1 on it. That's why you write range in the inverse function. You put the minus 1 on it. So that is it. I have formed the inverse function. I just need to make the g to the minus 1 the subject now, so that I need to use it here. So I need to make g to the minus 1 the subject. So how do I make it the subject? Carry away this 1 first and minus it, and then divide under this 2 steps process to make g to the minus 1 the subject. Right? So I'm going to get the x minus the 1. See the 1 gone over and become minus 1. And then divide the 2 under there. Divide the 2. So like you divide them both sides by 2. Divide the 2 under there. And that leaves me with the g to the minus 1. So that's it. So the g to the minus 1 equal this. And the f to the minus 1 equal that. And now I want to form my g of f. I will now want to form this. How do I form that? Or what do I form that? Using these 2 things now, I'll put them in a box each. Put this in a one little green box right here. And put this in a one little green box right here. I have my 2 things I want now. How do I do that? See here, I have to put the f to the minus 1 into the g to the minus 1. That's how I form the g to the minus 1 of f to the minus 1. Put the f into the g. See that? Put the f into the g. That's how I form it. Let's go back for the purple now. So therefore, my g to the minus 1 of f to the minus 1 is equal to, I put my F into my G. So it means, let me show you what happens now. Now let me use a green ink and show you. Let me take off this. Let me write it for you. Let's take off this higher up. That means that, use red. I'm taking all of the F to the minus 1. I'm bringing it and put it right here where the X is. That's why I put the F to the minus 1 into the G to the minus 1. See that? I'm trying to find this. Remember, see it up here, so this means F to the minus 1 into G to the minus 1. And that's what I'm executing down here now. Alright, so I'm doing G to the minus 1 of F to the minus 1. I'm going to work it now. So I'm putting the F to the minus 1 into the G to the minus 1. Talk to me now. Watch this now. It becomes X plus 5. X plus 5 over 3 minus 1 over 2. Tell me if you don't see that. Right here is where the X was here, so. Nobody see that? I'm going slowly and I'm trying to get my time. Nobody see that?
Yes, sir.
Yes, sir. Yes, sir. And then all I need to do now is show say this actually equal this. That's all I need to do now. Show say them two things are equal. All right? Easy. I'm gonna show that easy now. Watch this. I don't want this fraction up here, so to get rid of that fraction up there, I'm simply going to multiply my numerator by 3 and multiply by denominator by 3. Multiply them by 3 over 3, which is the same as multiplying by 1. All right? That's the magic of mathematics. This becomes equal to, we multiply 3 times this bracket. The 3 cancel with this 3 under here. All right? I'm going step by step, you know. And so I'm left with X plus 5. When I multiply the 3 by this negative 1, it becomes negative 3. It becomes negative 3 minus 3 divided. When I multiply this 3 by this 2, it becomes 6 under there, 6 under here. And then what you find now? This becomes equal to, see there, 5 minus 3 is a plus 2. So you get X plus 2 over 6. What you find? See G to the minus 1 of F to the minus 1. G to the minus 1 of F to the minus 1. So you see that both of them equal the same thing. See that? Two things are equal the same thing. See it? Two of them equal X plus 2 over 6. X plus 2 over 6. So two of them equal. See that? Therefore, it has been shown that the f of G r to the minus 1 is equal to the same thing as the G to the minus 1 of as the F to the minus 1, which is what? Which is X plus 2 over 6. Two of them equal X plus 2 over 6. I've shown it. And therefore that is quite easily brushed aside. Quite easily done. So you see that it only looks long because I start over and I take my time and I'm explaining and somebody wants to something do over and I'm going slowly and the first one we're doing. It's not so long after all, believe me. It's not very long as it looked in this session. Understand? It's not as long as it looks. So over here, let me mark it. Over here is where we found the G. Let me put it in purple. As we did. So over here is where we did the G. Oh man, in purple. Over here is where we did the G to the minus 1 of F to the minus 1. So that's how we do this on this side. We did this on this side. And show that the two of them work out to be the same. Right? They worked out to be the same thing, both of them. I need you to go and work this over by yourself, guys. More maths equals better maths. You need to work this very same question by yourself. Work it over from scratch. To prove the rule tend to be more work than to use the rule or apply the rule. You have to work out the whole thing where the left side is. See what it's equal to. Work out the whole thing where the right side is, and see that the two sides equal the same thing. That is why the two expressions are the same, because they equal the same thing. Any questions there? Before I move on to the next part, I don't think I'm gonna bother with the variations today. We'll pick up with the variations tomorrow because it's after 1 o'clock already. So we'll pick up with it, and I want you guys to focus on this. I don't want to do anything different. So tomorrow we're gonna start the class with some variations. It's very easy, the variations thing. I'm not gonna bother with the variations today. I'm gonna do that tomorrow. So I'm gonna do some more functions tomorrow, practice. I'm gonna do the variations, and then after do the variation, do a couple questions in the variation, do some questions in the functions. And that's what we're doing tomorrow. So I'm not gonna bother to move on to the variation today. We want to do one example where you're using the rule next, but I want to know if persons are kind of alright with what we just did a while ago. You feel alright, guys?
Yes, sir.
Yeah, you just need to practice.
Yes, sir.
Trust me, not rocket science, man. There's just the practice.
Yes, sir.
On the left side, we do the f of g first. After we do the f of g right here, work out what f of g is first, normal way. After f of g, then we inverse the f of g next right here and see what it equal to. And hold that, put on that one side. That's what we do first. Then now, we're coming for this side now. Coming for this side. How we do that side? We work out the f to the minus 1. That's what we did here. Work out the f to the minus 1. Then we work out the g to the minus 1. That's what we did here. Work out the g to the minus 1. After we work them out, we composite them by putting the f to the minus 1 into the g to the minus 1. That's what we did here. And I will simplify it down. Simplify it down and show us that the two things are the same. It's not difficult, guys. Believe me. It's not difficult. You can do it. I know you can do it. Right? You just need to do this very same example again by yourself first. This very example that we did, go home and do it by yourself. Well, you're at home, you're not going home, you're at home. Do it by yourself right after the class done. This very example. We work it out from scratch. Right? And then you're gonna look at the homework sheet and do a couple of those questions. But remember to prove the rule first, and then we're gonna look at some of the homework questions and maybe see what we're doing just before. But look, let us look now at the use the rule or apply the rule next. Let's look at that next. All right, so let's go back to this. Oh Lord, start over. Jeez, it started over. Let's find it again. Where is it? Bam. That's it. All right. So this is it now. So this was prove the rule. This is now apply the rule. So apply the rule question set here. We're looking at the one down here, so now. Down here, so now. Let me take this off the screen. Right, so we're looking at apply the rule now. All right, the second one. Example 2. So the second example, they give you those two functions. They ask you for this, f to the minus 1, and they ask you for g to the minus 1. And then the key word now is that they say hence. Now, the hence method is, most times in the exam, they will say hence or otherwise. In the exam, most times, they say hence or otherwise. Every time they say this question, they always say hence or otherwise. Find this. The hence method is easier because the hence means you're using these two things to find this thing. Now, in order to use those two things to find that one thing, what you have to know? You have to know that this thing is actually equal to, what is it equal to? Somebody tell me, what is this actually equal to? Somebody tell me, what is it equal to? f of g all to the minus 1 of x is equal to what? Tell me. Somebody tell me what it is equal to. Now the final answer now, in terms of this and this, what is it equal to? Nobody can tell me. It's equal to the same thing that was said. It's equal to the g to the minus 1 of the f to the minus 1. If the g comes second in here, it comes first out here. F comes first in here, it comes second out here. See that?
So would the x be beside of it?
You can put x beside it. You can put x beside it if you want, no matter. It no matter whether x beside it or not. That is just like a statement that's saying of x. Means they're just saying that they are function as of x. That's all it means, you know. The x are irrelevant. This x irrelevant. They could have given you just FGR to the minus 1 by itself. It's the same thing, you know, no difference. This x irrelevant. I mean, it just means that it's a function of x. It is in terms of x. That's what it means. The answer must have x in it when you're done. X would be your domain values. So some questions have it and some questions don't. Some questions give you this and some questions give you that with the of x. It don't make that no matter. It don't matter. Right? It's the same thing. Two of them is the same thing. This thing doing it one thing, you know. Right. Right? The two of them is the same thing, guys. So don't make this thing throw you off. So this still equal to g to the minus 1 of f to the minus 1. I'm gonna have to put an x, but I can put it or I don't put it. I can just no say that me I work out. So this means me I put the f to the minus 1 into the g to the minus 1. I'm done. So I'm have to do. Otherwise, you have to work out the whole of this from scratch. Or you work out the whole of that. You find the f of g and then inverse it. That's what you have to do if you are doing the otherwise method. The hence method, use them to your work out already and do it. Let's do it. Let's do it on the thing and show you. Let's do it. Let us do it. Do it. All right. I'm gonna make it smaller. I get a smaller picture. All right. So let me take a picture and show us how we do this one. So we're gonna do this question. All right. Let's do this one. All right, so we're trying to do this question right here. All right, so the first part says find f to the minus 1 and g to the minus 1. All right, so see it here now, they give us f of x. You know, write f. They give us f equals x minus 2. And we inverse that. We inverse that, the x becomes f to the minus 1 minus 2. Transpose that and becomes plus. So the f to the minus 1 becomes x plus 2. Right? And this really is f to the minus 1 of x. So that's it. F to the minus 1 of x, that's the first part. Equal x plus 2. And the second thing they gave us was g. So the second part is g. So the g is equal to 3x plus 4. That's what the g equals. 3x plus 4. And then again we inverse this. When we inverse that, the g becomes x and the x becomes g to the minus 1 plus 4. We want to leave this as a subject. So we'll get rid of this 4 first by subtracting and then divide under the 3. Same procedure every time with these linear functions. So it becomes x minus 4 over 3. That leaves me g to the minus 1. Now that I'm done, I can put in back of x. And this now is g to the minus 1. And them say, hence, find f of g all to the minus 1. So I can write it like this now. Hence, f of g all to the minus 1. We don't bother put on the of x. So write that. Hence, f of g all to the minus 1. What do I know it equal to? I'm going to write what I know it equal to. Let's put it in blue. Is actually equal to g to the minus 1 of f to the minus 1. That's what I know it's equal to. So how do I do that? What does this mean? This means I'm putting g to the minus 1. No, not g to the minus 1. I'm putting f to the minus 1. I'm putting f to the minus 1 into g to the minus 1 to get it. I don't have to work out this from scratch. The question said hence. I'm using the hence method. To use the hence method, you have to know say this equal this. So you have to know say this equal that. Otherwise you can't do the hence method. Notice the question never tell you what it equal to. Look at the question up here. You know, tell you say it equal this, you know. So you have to know say it equal that by knowing the rule. Right? But the otherwise method would still work to work out this if the question they say hence or otherwise. But no, it don't say hence or otherwise, it just say hence alone. So you have to know this if you're going to use hence alone. Alright? So we're working it out now. So putting the f to the minus 1 into the g to the minus 1. What does that mean? That means we're taking this thing that the f to the minus 1 is equal to and bringing it and putting it right there. That's what we're doing now. Nice and easy. So see it here now equals. It becomes x plus 2 minus 4 over 3.
Sir, I had disconnected from the meeting. I just say, where are we now?
We're doing this question and the recording is there. So all I have to do is get the recording and watch it when I finish.
All right,
Right?
thank you, sir.
Yeah. So this then becomes x minus 2, sorry. X minus 2, because 2 minus 4 is negative 2 over 3. That is the answer. If you put the f to the minus 1 into the g to the minus 1, that is the hence method. Now, suppose the question they say hence or otherwise. So the question that said hence or otherwise. So I'm putting the otherwise method down here. So, all right, then let me write it over here. So I'm write so this means f. This means f to the minus 1 into g to the minus. This means f to the minus 1 into g to the minus 1. That's what this means. All right, let me do an otherwise method right over here. If the question they say hence or otherwise. So this is otherwise. You couldn't do this question this way, because the question did not say hence or otherwise. The fortunate thing is that every year when I set this question, it always says hence or otherwise. But when I give the classwork on Wednesday, I'm going to say hence alone. So you have to know this rule to do my classwork. All right? Because when they say, if they say hence or otherwise, you can work it out from scratch. And the otherwise method is always longer. So when we do the otherwise method, I'm supposed to get this same answer, all right? That's what basically it's saying. So otherwise, look now. Otherwise, we're trying to find f of g r to the minus 1. To do that way, we have to find f of g first. So we can say no. Starting. F of g means g into f. So it means this one into this one right there, right? G into f. That's what it means. So it means that we will get a 3x plus 4 where the x was minus 2. And then the f of g would become 3x plus 2. Then after it becomes 3x plus 2, we inverse it now. We're trying to get to this f of g r to the minus 1. So the f of g will become x, and the x there will become f of g r to the minus 1 plus 2. And then we're trying to make this the subject now. So we'll make that the subject. Carry over the 2, subtract it, and then divide under 3. Right? And so it would be x minus 2 after we carry over the 2, and then divide the 3 under there, over 3 equals f of g r to the minus 1. And say that this thing is same as that thing. So you could get it the otherwise method if the question says hence or otherwise. But the hence method, you just have to know the rule. You have to already know that this thing where they want is actually equal to this thing. You have to know, so it equal this. You have to know that it is equal to that. All right. Any questions there? I could look at what the homework is gonna be. Any questions there before we take a look at the homework? No question. So the homework is homework number 2. So let us look at that. Let us look at that. Let us look at that, guys. Alright, the homework. The homework is here. Alright, so we're not gonna bother with the variations today, right? We're gonna deal with the variations tomorrow. Alright, so we're basically looking at homework number 2, guys. See here, homework number 2, right? So for example, this question, alright, see here, find g to the minus 1, hence find x for g of x equal to 6. That is using inverse function to solve the equation. So remember, if g of x equals 6, and x equals g to the minus 1 of 6. That's how you do that question, right? The part of it right there. So that says using inverse function to solve the equation. That one. Let me see this one down here. This one now is, see there, inverse of a composite function. See there? Is an inverse of a composite function example right here. See? Prove the rule. So you see, it asks you to find everything first. And then it asks you to prove this. Alright? It asks you to prove it. So after work out this right here, which is the same thing, you have to now work out this part and show that they are the same. Alright? That's inverse of a composite function example right there, using these two functions. Alright, let's look at the next one. The next one is undefined. See here, state the value of x for which a function is not defined. Remember, when it's not defined, the denominator is equal to 0. And it is not defined. So you're gonna do that one as well. Alright, so that is an undefined example right there. Let me see this one now. So this one now is h of x, k of x. This one special. Yeah, maybe we can do the inverse of a composite function there, right there. See, h of k r to the minus 1. All right. So that one is about really. That's that. Let's look at this one now. This one up here. What are they testing? See it again. Hence or otherwise. Write an expression for this. So they ask for this and they ask for that. And then they want you to find this now. G of fr to the minus 1. And so to do that, you have to know that this is actually equal to, since the f comes second, it comes first now. F to the minus 1 of g to the minus 1. So to get this, we just put this g to the minus 1 into this f to the minus 1. See there? G to the minus 1 into f to the minus 1. All right? So that is that. So that's an inverse function one. The user, no, prove is a user rule one this. Use rule. Example down here was a prove the rule. See there? Example down here was a prove the rule example. Show that. Up here now we have to use the rule because they don't tell us how it equal to. So we have to know so it equal this. And then work it out. Alright? But them say hence or otherwise. Or otherwise. So it means that we could work this out from scratch. It's always easier because we have these already to use the rule. Alright, so that is that right there. And then this example now is a composite function one. You see it? Them give us a composite function. We're breaking the composite function. See there? They tell us that k of x is equal to that, and they tell us it is a composite. and then tell us that the K is actually G of F. And what do they want us to do? They want us to find the F of X and the G of X. So we're splitting this into two simple functions. And then now they're giving us a prove the rule question right here. Remember the K is really G of F, you know. So this is the same as saying G of F r to the minus 1 equal F to the minus 1 of G to the minus 1. This is a show it, prove it. So this is a prove this rule. Prove it. But they kind of give us the K as G of F. All right, so that last one. So these questions basically covered what we did today. All right, composite function, prove the rule, composite function, inverse of a composite function, prove rule, inverse of a composite function, use rule, undefined, using composite function, using inverse function to solve the equation. All right, which basically is what we did today. These things. So these set of questions cover that. Right, what did today? See there, and then this page now is variations, which we're gonna do this now tomorrow. All right, this page is variation. My intention was to do this topic today, but because I was spending so much time on this one, and we have tomorrow, we'll do these tomorrow. All right, we'll do this topic tomorrow. All right, that is it, guys. That is it. Today was a nice class. I like the interaction. I like the questions and the people answering questions and stuff. I like it. That's how we must keep the class lively, engaged, everybody paying attention. All right, people say the wrong thing and learn from the mistakes. Very good, right? Because it means that we clear up certain little misconception when you make a little mistake, and I'm able to clarify and say, no, do it, do this, do that. That is not right. Whatever. That's the beauty about it. All right, so we need to continue having the class that way, having the interaction in the class. Remember, guys, you can send me WhatsApp, send me WhatsApp messages, right? Do your work, do your examples, send them to me, sir. This right, that right. What do you think about this, sir? Interact. I'll take your messages all day, every day. If I don't answer right away, because maybe I'm busy, when I get the chance, I will answer. I will answer your messages. All right. So when you practice your questions, send me your questions, send me your solutions, and we'll look at them for you. All right. So that's how we improve. We have a class tomorrow. The aim is for 3 o'clock. If I can't keep it at 3 o'clock for whatever reason, then you know it's at 5. Always we're trying for 3 o'clock first. So be prepared for. All right, sorry about that, guys. All right, so that's it. So tomorrow, 3 o'clock, we pick it up again. All right. So have a wonderful evening. Go and work those questions that we did, the same examples that we did. Do those questions over again by yourself first, and then do the homework number 2. Do the homework number 2. Leave the variations question. We deal with those tomorrow. All right. Everybody good?
Yes, Dad.
Yes, sir.
All right. Bye. See you
Wait,
tomorrow.
Mr. Shaw. Mr. Shaw.
Yes.
What time is class tomorrow?
3 o'clock.
3 o'clock.
3 o'clock.
Yes,
That's a problem for you?
no, sir. Remember that case is starting tomorrow again, sir.
Yeah, man, but they finish by 3 o'clock.
Okay, yes, sir.
Yeah, man. So if they finish 3 o'clock, you just roll in, make a deal with our thing.
Yes, sir.
All right? Roll in, we deal with our thing.
Thanks, sir.
We're trying for the 3 o'clock, because I think we have a little bit more time. People, 3 o'clock, I think 3 o'clock kind of good now. So we work with the 3 o'clock, because everybody at home and thing. And you see, the thing is, when we get into 5 o'clock, persons reaching home, your parents reaching home, your siblings reaching home and disturbing the class and stuff like that. So, I think 3 o'clock kind of better because you're at home and not everybody at home. Who's at work is at work. So, make we try to work with the 3 o'clock when you're at home. We try for the 3 o'clock. If we have to go for 5, then we will go for 5. But once we can have it at 3, we will have it at 3. And once there's a change, you will know. I send a message to the group and you will know. Right? But so far, the 3 o'clock working well. Everybody tend to come on at 3 so far. So, you know, I could continue working with 3, and I don't hear a lot of disturbance in the background when persons open the mic to talk and things. So I could continue working with 3 o'clock for the time being. All right, so far so good, guys. So let us continue. And remember, communication is very important in this session, in this program. So send me your messages, I'll respond. All right, and you can call me on WhatsApp, send me a message. If I feel like it's a thing where I need to call you and talk to you, I'll call you and we talk it out. Right, so even somebody today said they didn't understand something so clearly, no problem. Later, you can send me a message, I'll take a time and call you, and we can go through it. Not a problem. All right, we want to make sure that everybody move ahead together. Don't want anybody get left behind. I don't want any gaps in your knowledge. Because we're moving on to something next week, something new next week, a new topic next week. So we need to master this one before we move on. I reach a good level before we move on. All right, so don't be afraid to communicate with me, guys. Send me your questions. I'll deal with it for you. No problem at all. All right. All
Yes,
right.
sir.
So, all right then. Cool. So later. Bye. I'm
Bye
gonna end this.
then.
Bye, sir.
Okay. Okay.
Yes,
Bye.
sir.
Bye. Bye. Bye.